Okay, that works. So, all right, I didn't take the time to video when I actually implemented the binary tree algorithm, but I am going to make a video. Might be multi-part, but we'll see how far we get in here. We're basically going to run through the initialization for the next algorithm. See, this one's binary tree algorithm, and it's implemented basically right here. Or that's initialized right there. It's implemented basically right here, and there, and there. And then this is the finish of it right here. So it looks like what we do is we initialize this and we initialize that. Then we do the easy stuff for that algorithm. And then we actually implement the algorithm. And everything from the algorithm goes into this array right here, maze top left. Okay. So we're going to do bool. Whoa. Maze top right. Okay. 90, 55. Okay. We'll still use this for Dijkstra's algorithm later. We will use that. Let's just copy this down below, not here. So here's Dijkstra's results. Okay, good. So then we want to do the second. Okay, now implement Sidewinder algorithm. Okay. And the Sidewinder algorithm works very similar to the binary tree, where you start at the bottom of the maze, which we will actually start at the bottom of the maze this time instead of the top. Or we could start at the top and actually tweak it to be able to start at the top. But anyways, what it does is it starts at the, let's just say the bottom left, and it would move to the right, and it would randomly choose at the first cell. It's going to choose to open the wall to the right or open the wall up. And the trick is, when it opens the wall up, as it opens walls, as the algorithm runs and it opens walls to the right, it keeps track of the number of open walls to the right in that particular run until you close out the run. And the run of cells either ends at the end of the row, or it ends when you end up randomly choosing to go, in this case, north. We could tweak it and start on the north wall and go south, but I don't want to do that right now. We could, but anyways. So as it's randomly choosing to go north or east, you go east until you come to a point where the computer has chosen to go north. And at that point, you go back and randomly choose one of the cells from the run and go north from that cell. And then you clear all those cells and you go to the next one. So what we need to keep track of, and actually all we need to do to keep track of that is just cells run, an integer. That's it. Because basically, as it goes forward, we're just going to count the number of cells in the run, so that when we go to decide which random one, we'll just go to this integer and we will go back that number of cells back from 0 to that number. We will randomize it, and then we will go up from there. And then, yeah. So maze top right, and then also temp maze, we're going to reset. See, at this point right here, we don't need temp maze anymore because we've changed the color of the cells in that on the screen. We're actually affecting the vertices here. to correspond with actually what's in the map of the maze. So that's really cool. So we will reset or initialize temp maze. Excuse me, and maze. I had a beer just a little bit ago, and then I just woke up. Well, it was 5 hours ago, and then I just woke up and had some freshly squeezed orange juice. Thank you. Okay, reset or initialize temp maze and maze top right. Okay, so we will get ready to actually do that. And I'm just gonna copy code. I'm just waking up. Isn't that great, kids? Isn't that great? Okay, so we need to do this here. Okay, go down to here. I love this. Keeps track of where you were. Okay, so temp maze, that's good. This here, top left, top right. There. So that's going to reset, which is great, and then initialize the maze. Okay. There. So for Sidewinder, we're already initialized. That's great. See, we're doing it. Now, what else? What else do we need to do? This is so much easier than now that I've already done the first one. Oh, right, the easy stuff. Okay, so for the Sidewinder algorithm, right? Because the decision is to go north, what ends up happening is the northern wall ends up being just a clear corridor. So we will clear the northern wall inside the maze at the top. Okay. So we're going to clear the northern wall. That'll be first. So the northern wall for int I equals 0. I is less than 90. I plus plus. And we're going to do this. Are we going to do this? How did I do it? I never know what I did. Set northern wall, eastern wall open. So we do it in maze top. Okay, right. So we'll actually do it maze top right. So each time through, we're going to go with a different I. We want the top wall. So it's, what is that? I cleared the northern wall up here, so hold on. So the top left northern wall right here, or no, east-west horizontal path. Oh, right, that's what I want to do. So I 0, I plus 1, 0. Right. Let me just copy this because my brain is right now fried a little bit because of the beer. Well, it was 14% alcohol. It's a good beer. Okay, maze top right. At least I know that's going to be different. Oops, not just there. Okay, so does that work? And if I plus 1 is less than 90, great. So the entire wall is free. There's no movement on the northern wall, so we don't actually need to compute that. So that's great. East-west horizontal path. Perfect. Perfect. Now, so far so good. So now we just do the rest of the Sidewinder. I equals 0. I is less than 90. I plus plus. Whoops, why do I do that? Okay. Actually, you know what? Let's, because I always think about this as 0, 0 being the top left. So if we're going to start in the at the bottom, so we're going to start at 50 and go to 0. So now we're going to start on the at 0x and 50 y. So we're going to move this way. Yeah, we'll move that way. Okay. So we're going to start at 50, which actually isn't right. We're going to start at 49, as long as we're greater than -1. Haha. Okay, so now that'll cover 0. And then what we don't need to do, actually we can go greater than 0 because we're not going to worry about the top wall. We just took care of that. Okay. So at each cell, what we do is we decide to go east and take down the wall, or go north and end the run. Randomly choose north wall. Exit. Take down the wall. Okay, so if random so let's say we decide to go east. So take down wall east, increment run. Else go north, choose from run, open wall north, reset run variable. Seems easy, right? Right? Okay. That, I'm telling myself it seems easy. So, So, since we already got our comments there. Okay, so far so good. So in this case, when we're going east, we just go to take down the wall to the east. Okay, and how do we do that up here? Is it actually in the... So when we got to actually doing the decision, maze top left, so it'd be maze... Okay. So maze top right, sub I, sub j, e equals true. It's open. Increment the run variable. What's the run variable? I already forgot. Cells run. Okay. Does that work? Are we happy, computer? So basically we're going to take down the wall to the east, okay, and the cells run goes plus plus. But in order to also take down the wall to the east, we need to go what's our I plus 1? If I plus 1 wait a minute. Hold on. If we go east and we're at the very end, that's going to automatically end the run. All right, let's not worry about that right now. Let's just say if I plus 1, okay, is less than 90. Then do this. So maze top right, we're going to J, going to west, equals true. Okay, so we just go over one block and then change the west wall to be true. So that's great, good job. Excellent job. And we increase the run right there. What was that? Can you drag and drop with the, that's weird. I did not know that you can drag and drop on a selection. Okay, learned something new there. Okay. Okay, so in the event that the computer chooses north, we're going to choose a random wall from the run. So if cells run is greater than 0, there will be something there. Otherwise, there. We will choose random wall from run of cells. Then we will open the wall north at that point, and then we will reset the run variable. Okay, if the run variable is at 0, we will just open the wall north at current point, and just for giggles, reset the run variable. So actually we're going to take this out of both of these. And then either way, when the computer chooses that, we're going to reset the run variable. So cells run equals 0. So that way we only have code for resetting it once rather than twice. Yeah, whatever. Okay, choose random, just a small little optimization. Choose a random wall from the run of cells, open the wall north at that point. So what we want to do is go back. So excuse me. Again. Okay, so we're going to go I minus rand percent cells run. Basically, that'll do it right there. And then J. And actually, since we're we're going up, north wall equals true. Okay. So maze top right I minus 0 to cells run. Okay, so it could be the cell that we're in, or it could be however many runs back. That's going to be true. Then you want to go maze top right. Actually everything the same. Except for J minus 1. Oh, and I thought about that wrong. So that's S. Sorry. And this is N. Because if you go up 1 and then the southern wall, and you stay right where you're at in the northern wall. Okay. Very good. That was a lot easier than I thought. Open the wall north at the current point. Maze top right. Open the wall north at the current point. That's right here. Reset the run variable. Is that it? Are we done? How long did that take? 20 minutes? What the heck? This is... Huh. So I guess the first one just took me forever. This one was 20 minutes. Okay, so that's really cool. Okay, so now that we've got that, interesting. Okay, so I is through 90, J is 49. Okay. Okay, so theoretically we were done right there at that point. So then what we can do is what? Right, we want to run Dijkstra's through it. So, okay. Okay, have we done anything with temp maze yet? No. Just maze top right. Top right. Okay. So then we implement Dijkstra's, but I'm just going to copy it. Hold on. And then we'll just have to change the variable for the maze. We're good. And then change that. Okay, this is way easier than I thought. I know I need to make this a function rather than doing it like this, but okay, so now we're going to go back up, up, up. Sidewinder. Here we go. So this can be the same. That's good. Current frontier, count neighbors, temp maze equals current frontier, maze top left. Okay. And maze top left. Temp maze, current frontier, maze top left. I know there's a better way to do this with the replace, but you know, whatever. But this works just as well. Okay. Temp maze, temp index. Huh. Oh, and then this right here. So we're going to go from 90 to 180. Won't that do it? Won't that do it? Yeah, actually it will. I'll be amazed if this actually works. I'll be amazed. Something's gonna go wrong. Oh, what the heck? Oh, right. Hold on, take me to it. Show me. Show me your troubles. Show me your sorrows. Actually, doesn't that just get reset inside there? Yeah, so we don't need this out here. That's just for... Now I'll be amazed if it actually works. It's gonna compile and everything. It's, huh, let's see if it works. Did that work? I don't know. I think I want to change the thing right here. Back to what it was before this whole show started. it's too dark of a color. Do it again. Well, it looks interesting. I'm kind of guessing that that's not what it's supposed to look like. I don't know. There's a pattern. It's a random pattern. I can't tell. All right, let me look at this more carefully again here. Oh, right, so j minus 1 is always good. Okay, good. Let's reset run variable. See here it does cells run plus plus. Starts out at 0. Oh, and also, shoot. We need to do it at the end of the row too. But because that could be a problem. Because if it gets to the end of the row and the cells run, yeah, hold on. You know what, for right now, I'm going to just clumsily go like this. So as soon as it exits that loop, right, then we're going to reset cells run right here too. Just, to be clumsy about it, but to also do a little cleanup. Reset run variable at end of each row. There. Not that this is going to have a huge effect on the crazy look of it, but, well, it does something, it does something. I'm just wondering what the heck it's doing. See, it looks interesting. There's a pattern there. I just am unsure. So bizarre. I don't know what to think. Anyways, so that's how I don't know if that's correct or not. I really don't know. I've got the book over here for looking at the Sidewinder algorithm. I don't have my webcam on to show you. Otherwise I would, but the Sidewinder algorithm, it has a bias, kind of a vertical bias in the center, but it looks like it's got many vertical biases. Okay, well that's it for today's new word, kids. We're going to end the video. Be sure to like and subscribe and comment in the section below the video.